So here's question 8, and we are required to get f prime x. So unlike the previous question that needed us to get the second derivative, here we are required to get the first derivative only. If f of x is equal to 2x to the power 4 minus 3x plus a squared. Now, just by looking at the question, I know that the a squared might confuse you a bit. Why do we have another variable? Why are we seeing another letter? But what you guys need to remember is that this is a function in terms of x. Any other letter that appears will play the role of a constant. So right now our a squared will be treated as a constant because this function is in terms of x. It is f of x, not f of a. So a would be a constant. Even if we were to have any other letter being added on, such as y, z, b, c, d, etc., any letter at all, any other letter other than x would be treated as a constant. So let's go through our preparation steps. We do not have brackets, we do not have surds. All of our variables are in the numerator, so we are ready to differentiate. So we're going to have f prime x is equal to, differentiating the first term, take the exponent, multiply with the coefficient. 4 times 2 is 8, and minus 1 from the exponent. So that gives us 8x cubed. For the second term, we've got negative 3x, and I showed you guys this rule in one of the previous questions that we've done, where if we have cx, where c is the coefficient and x is the variable, and x has an exponent of 1, much like what we have here with negative 3x, when you differentiate that, x falls away and you're just left with the coefficient. So here, where we have negative 3x, x will fall away and we're left with negative 3. Then for the next part, where we've got the a squared, the next rule, and again, I've mentioned this in one of the previous videos, where if you have a constant and you're going to differentiate this constant, the derivative of a constant is 0. So the derivative of the positive a squared is 0. Now, obviously, we do not need to say plus 0, so we can just leave that as is. Now, just to make sure we have differentiated all 3 terms, we've used the correct notation, and we've got positive exponents only. So this is our final answer.